Okay, really quick here, a little video for Physics 11H. I'm going to derive two more equations for you that we're going to use for kinematics, all right? So I'm going to start with the ones we already know and the ones we already defined. So the first one we have is the average, oh, that marker's done for. I'm down here, let's see, okay. Average, oh, that marker's done for two. Oh, wow, Harmon, you're off to a great start here. So, fresh pack it is. Fresh pack. All right. There we go. Average velocity equals displacement over time. That's one of them. Then we also had average velocity equals v initial plus v final over 2. And then we also had acceleration equals change in velocity over time, which equals v final minus v initial over 2. All right? So those are our three main equations now. In fact, this one can actually be rewritten as, if you solve this equation for v final, or that's not over 2, that's over t, my bad. Multiply both sides by t, and you get v final equals v initial plus the acceleration times time. All right? Well, one of the things we've had to do a couple times now is solve this acceleration. We know the acceleration, right? And we don't know the time. And we solve for time and plug it into average velocity. Then we set that equal to this, right? So I could number these equations, I suppose. I could say, okay, this is equation 1, equation 2, and I'll call this one equation 3. All right. So here's what we're going to do. I'm going to show you that one first, okay? So we know the acceleration, so well, actually, let me erase this so I have a little more room. All right, well, I'll do it over here. We know the acceleration, so A equals v final minus v initial over t. All right, I'm going to solve this for t, so I get t equals v final minus v initial over a. Cool. And then I'm going to plug this into this equation, so I get v average. I get v, so this is, put this into equation 1 now. We get v average equals delta x over v final minus v initial over a. Okay, this is where we're at so far. All right, so now I'm going to take this equation 2, I'm going to plug equation 2 in here. All right, I'm going to write this up here now. Well, yeah, let me write this up here and then we'll go from there. So v initial plus v final over 2 equals, let's rearrange this here. The a can come upstairs, right? So it's a delta x times v final minus v initial. All right, so that's really important. I'm going to erase what I did here. All right, I'm going to erase this. I'm going to rewrite this equation a little bit bigger here. V initial plus V final over 2 equals A delta X over V final minus V initial. Okay? Alright, so we've eliminated time as an unknown here, but this equation is very clunky, right? This is not a good equation. So we're going to simplify this down to one line. So what we're going to do here is cross multiply, right? So this side ends up being, we're going to have to FOIL here, which you might say, what the heck, a FOIL, Harmon? I don't want a FOIL. Well, you guys should be good at that. So I bring this, I multiply bottom times top here, bottom times top here equals 2a delta x. All right, so the 2 just goes upstairs. And I'm going to FOIL this side. All right, so yep, I still do this sometimes, right? I think about how I FOIL v final times v initial, v final, v initial. You know, outside you might do next here, which is plus v final squared. Inside here, minus v initial squared. And last, right, minus v initial, v final equals 2a delta x. Okay, so this and this cancel. We have v final squared minus v initial squared equals 2a delta x. And the way we write it in the end is v final squared equals v initial squared plus 2a delta x. And there it is. Boom. A new physics equation. A little bit in the glare. I apologize for that. V final squared equals v initial squared plus 2a delta x. That is often called the v squared equation or the timeless equation. So we call it the v squared equation. And I think Mr. Kluin prefers to say the timeless equation. Most people know if you say, hey, we're going to use the v squared kinematic equation or the timeless kinematic equation for constant accelerations, they'll know it means this formula here. All right? Most people know that. All right, so we'll call that equation, I guess we'll call this equation 4. We'll call this one equation 5. And that's a really useful one, right? Because you really, often the final or initial velocity is 0, right? So really you only need one of the velocities typically, and one other thing like delta x or a or something, and you can figure out important stuff from there. Often what we have to do is take the square root of both sides to find the answer. We end up with v final equals square root of 2a delta x usually. If you drop something, for instance, it starts from rest. Acceleration ends up being gravity, 9.8 meters per second squared. Delta x ends up being how far it falls. So you take the square root of both sides and so on. We'll look at that later on. Now the other one is a rearrangement of number 1 essentially. You might remember number 1 can be rearranged to read delta x equals average velocity times time. All right, average velocity times time, that's cool. Let's plug in average velocity for that. You know, so what if it's accelerating is the question, right? Let's say you don't know the final velocity, right? So you can't figure out the average, but you know the acceleration, you know the time. You could always find the average velocity, but let's just, you know, move ahead with this as if we didn't know the final velocity. So we couldn't find the average. So I'm going to put in the average velocity here and try to eliminate final velocity as a variable. All right, so v initial plus v final over 2 times t. Okay, cool. Now I'm going to take this equation down here, number 4. I'm going to put it in for v final. All right. All right. So delta x equals v initial plus, then I'm going to put in v initial plus at, that's all on the top, over 2 times t. All right. Okay, so let me simplify this down a little bit. So v initial plus v initial, delta x equals 2 v initial, and I'm going to multiply the t through across the top 2. 2 v initial t, that's me adding those two together, plus at squared, which is multiplying this by this term, by this term, by this term, and distributing that t across the top, right? So I guess I added the v initial together first and then multiplied by t. So 2 v initial t plus 1 plus at squared, and then it's all divided by 2. All right. So let me go back up top here. I'm writing these equations kind of large. We're going to simplify this a little bit more. Delta x equals, well, this is like 2v initial t over 2 plus at squared over 2. So 2v initial t over 2. I'm going to split it up. Plus at squared over 2. And then what we do in the end is write it like this. Delta x equals 1/2 at squared plus v initial t. And that's the way we write that equation in the end. All right? And that we'll call equation 6. And equation 6 has a name that we call El Grande. I have no idea how to do accents on Spanish words. I apologize. El Grande. I had a physics professor in Buffalo who was a funny guy. I think Mr. Mort bought in his 60s, and you know, a little different. But always started class with a pun, a really good pun too. I guess that's a difference between Mr. Mort. Walt's puns were really good. Mort's are good, but Walt's were special. And he called this equation El Grande, 1/2 at squared plus v initial t. So students have had me in the last couple years know that equation as El Grande. Nobody knows what you're talking about if you call it El Grande, though. So don't, you know. And often we rewrite this one. We expand out delta x to be x final minus x initial equals 1/2 at squared plus v initial t. And then we say, okay, so then the final position is 1/2 at squared plus v initial t. And then this x initial ends up over here on the right side. And we like writing it like that because then it follows the quadratic formula, right? Like y equals ax squared plus bx plus c, right? So it looks like the quadratic form that you guys know. But as long as you kind of think of it like this, you should be good to go. So really, these are the main kinematic formulas now. All right. We'll be getting an equation sheet very soon. I don't give it to you like this. I give it to you as displacement. So you can figure out the final position. And there they are. These are constant acceleration equations of motion. All right, constant acceleration equations of motion, done and derived. Now you can start trying to use these, and that'll be another video. How do we get going using these? This one I would watch on high speed and not get too hung up if you got lost in the mathematics here. All right, we'll talk to you later.